the logarithmic function. Okay. First, let us see why the logarithm, where it comes from. I mean, why people thought about the weird function called logarithm. Suppose I ask you the following question: what is the power of 2 that gives me the number 3? Which power of 2 gives me the number 3? What will be your answer? Any idea? Not a trivial question. So what will be your hunch? What would be an estimate? Anything? Okay, you can either talk or write on chat. Don't keep quiet. Any idea? So let us locate it. It's gonna be between 1 and 2. Does this make sense? 2 to the 1 is 2, 2 to the power 2 is 4, so the number has to be somewhere between 1 and 2. And I don't know, I mean, it's not really an easy number to evaluate. So we can do trial and error. So that's really where the problem comes. We can do trial and error and try different values of here. So we can try 1.2, 1.3, 1.5. And if we do a lot of trial and error, we realize that something like that will do it. Okay? This number here, it means the power of 2, that gives me 3. We are going to give it a name. And this will be called the logarithm of 3 with base 2. So let's write this down. The power of 2. The power, this one here, the power of 2. That give us 3 is called the logarithm of 3 with base 2. It's called the logarithm of 3 with base 2. And it has a notation. And is denoted by logarithm of 3 with base 2. So based on my trial and error, the logarithm of 3 with base 2 is the 1.584. Okay, so the logarithm is a hard function. The reason it's a hard function is because it's after the power of 2, which gives me a 3. Okay, another example. Suppose I ask you which power of 3, let us say, will give me 8. That's again a difficult problem. So again, trial and error will give me, this is equal almost, let me see if I computed it. Okay, what's this power? This power here that gives me 8, we will call it the logarithm of 8 with base 3. So the logarithm of 8 with base 3 is actually this power that will give me 8. So now let us generalize and define the definition of logarithm. So definition. Let b be a positive number. Then the logarithm of x, of a number x, with base b denoted by logarithm of x with base b is the power. Power, it means the exponent. It's the power of b that gives x. In other words, when I'm thinking about log b of x, so I rewrite that's a power of b that gives x. In a more mathematical way, log b of x equal to y means the following. What's the log b? The log b is the power of b that gives me the number x. So that's the log of b. So it means the output of the log of x is the power that I should raise b to give me x. So now I'm going to give you a bunch of questions, very simple one, and I would like immediately your answers. So evaluate. What's the log base 6 of 36? Means I'm asking you for the power of 6, that's the base, that gives me 36. So the output of the log is the power of 6. So I want question very quickly. Equal to 200% correct. Okay, I proceed. Find log base 8 of 2. Again, I'm expecting answers quickly. 8 is the base. The log by definition is the power that gives me 2. It's 1/3. Okay. A to the power a third will give me 2. Okay, we proceed. What's the log? Base 2 of 1/16. Again, the same question. The power of 2 that gives me 1/16. -4, do you guys agree with Ryan? -4, absolutely correct, because 1/16 is 1/2 to the power 4. 2 to the power 4 is 2 to the -4. So my power here is absolutely -4. So that's really the output. The output of the log is the power of the base. Right. So now two more. What's the log base b of b? Oh, sorry. Okay. All right, I'm equal to 1. Because again, what's the output? What's the output of b that gives me b? This is 1. All right. What's the log base b of 1? Again, the power of b that gives me 1. The power of b is equal to 0. All right. One last one. What's the log base b of -1? Yeah, I'm asking the same question. Means what is the power of b that gives me -1? Sorry, 1 minute. I don't know why this is zooming out here like this. Okay, I'm listening or reading, whatever. What's the power of b that gives me -1? If you don't want to write, just say something. Anybody? What's the answer? What's log b for minus 1? That means I'm looking for the power of b that gives me minus 1. Anyone? No? Keep thinking. Can you remember what we did in class yesterday? And I emphasized this a lot. Remember what I said in class today, yesterday. If I take exactly, it's not defined. If you take 2 to any power, whatever the power is, can we get a negative number? No way. Because we said that if you take 2 even to the power minus 100, this is 1 over 2 to the 100, which is a positive number. It's absolutely not possible. Log of minus 1 is absolutely not defined. Why it's not defined? Because b to any power is a positive number. So that is not possible. There is no way I can put a negative number inside the log. So the first important note is says the following, that log base b of x is defined. It means it makes sense. It's defined only for x positive. So the log makes sense only if x, this term, is positive. If you have a negative number, this is absolutely nonsense. Okay. And the reason is exactly since if you take b, regardless which power you put on, it's a positive number. And x is, the log is the power that gives me x, and that's impossible. Now, two special logarithms are the one that we will be dealing with the most. So two special bases. Two special bases. Okay, first we have base 10. If I take b to be 10, then the common logarithm so the common logarithm is the logarithm with base 10. So the common log is the logarithm with base 10 and denoted by log, L-O-G. There is no base, that by log. So log of x means is the power of 10 that gives x. So log x is the power of 10 that gives x. So more mathematically written, log x equal to y means that 10 to the power y is equal to x. So the log, the output is the power of 10 that gives me x. Right. Another log, which is another base that is the one that we will use the most, is so first b equal 10. This is called the common log. And then another base which is used a lot is b equal to e. And this will be called the natural logarithm. So b equal to e, we have the natural logarithm. So when we don't write log, we don't write any base, it means the base is 10. Now the natural logarithm. So the natural logarithm is the logarithm with base e, and it's denoted by ln. There is nothing, it's just denoted by ln. So what is ln of x? So ln of x is the power of e that gives me x. So it's a power. And mathematically, and this is the one that we will use the most, the natural log. So ln of x equal to y means if you take e, so the ln is the power e to the y equal to x. Okay. So if I write, so if you see something like that, somebody said, okay, ln of 2 is 0.69. What does it mean to us? It means that if I take e to the power of 0.69, I get 2 back. That's really the meaning of the log. So log 2 equals 0.69. It means the output of log 2 is the power of e that gives me 2. With this in mind, I want you to evaluate the following expression. Okay, evaluate. What do I want to evaluate? Log, so that's the common log of 1 over 10. Okay, that's the common log. It means the base here is 10. Again, minus 1, everybody tells minus 1, everybody is correct. ln of e, quickly. ln of p, it means I'm after the power of e that gives me e. That's 1. ln of 1, the power of e that gives me 1. No, not e, it's 0. Because e to the 0 equal 1. Absolute memory for all those, for this and this, not for this one. ln of e square. Simply power of e that gives me e square, 2. And the last one, what's ln of the square root of e? The power of e that gives me the square root of e. Absolutely a half. So now let us talk about the properties. Yes, absolutely, guys. So now let's talk about the properties of the logarithm. And I will explain as much as possible each one. If I move the paper and you guys are not done writing, please let me know. Shout. So properties of the logarithm. We're going to have 2 sets of property. The first one is, I said it, but I repeat it. Log b of x is defined only for x positive. And that's very important. Means we can only put here, we can only input positive number. 2. Log base b of b is equal to 1. And in particular, ln of e is equal to 1. Third, log b of 1 is equal to 0. In particular, so everything I say, I tell you what happened to the natural log because that's the one we will be working with the most. 4. Log base b, sorry about that, of b to the x equal to what? I stop now and I want an answer. Equal to x, because by definition, that's really the definition. What's the definition of the log? It means you're asking yourself, to which power you should raise b to get b to the x? Okay, I should raise it to the power x. That's the definition. So in particular, ln e to the x is equal to x. Okay, the last property, not the last property, so the first bunch of properties, and b of x is equal to what? Okay, so if you take b and you raise it to the power log b of x, what should we get back? So for example, if I take 10 to the power log x, what do you think I should get? No, I want you to think a little bit. I know that's confusing. So let us recall, what's the definition of the log? What's the definition of the log? Log x, by definition, is what? Is the power of 10. I'm taking the natural log too, so I will not make too abstract. It's the power of 10. So the log, by definition, is the power of 10 that gives me x back. So in other words, so what do you think the answer of 10 to the log x is going to be? What's the definition? The log, by definition, is the power that gives you x. That's the definition of it. Means if I take 10 to the power of log x, what should I get here? I should get x back. That's the definition of the log. It is the power of 10 that gives me x. So 10 to the log x is going to give me x. If I take e to the ln of x, this is equal to what? What's the ln of x? By definition, ln of x is the power of e that gives me x back. So the ln is this power right there. So to make it a little bit more realistic, when I say ln of 2 and I pick up my calculator and I get 0.69, what does the 0.69 represent? What should I raise e to get 2? That's what the 0.69 is. So it means e to the ln of 2, which is e to the 0.69, is equal to 2. Okay, so this means that if you take b to the power log b to the x, you're going to get x back. In particular, e to the ln of x, this gives you x back. That's the definition of ln. That's really the reason is that's the definition of ln. Okay, so just to make this idea very, so e to the ln of 2 is 2. That's the definition of ln. E to the ln of 3 is equal to 3. That's what I'm trying to say. And so on and so forth. Okay, all those properties are absolutely essential for us, especially the ln, because I'm going to be working with it the most. Okay. Now, algebraic property of the logarithm. The logarithm. Okay, so I know that you've seen all this, so let me see. If I take the log of the product of two terms, what does the log 2 to the product? Any recollection, anyone? Anybody? It just turned the product into a sum. E of y. So in particular, ln of the product is ln of x plus the ln of y. It turns the product into the sum. So for example, if I tell you what is ln, so that's what is, if I have the product, ln of 2 times 3, it means ln of 6 is ln of 2 plus the ln of 3. If I pick my calculator and I evaluate ln of 6, then I evaluate ln of 2 plus ln of 3, those are exactly the same. Second properties. What does the log, one of the property that we will use the most for the log. I mean, all of them will be used. X to the n. If I take a number to the power n and I take the log of it, what does the ln or the log, sorry, do to that? Again, I want you to try to remember those properties. Anybody remember what does exactly? It takes the power and bring it down. So it's n times log b of x. So in particular, ln of x to the n is n times the log of x. Okay, so what does this mean? So let us say you're evaluating ln of 8. Now 8 is 2 to the power 3. What this property tells me that this is equal to is the same thing as taking the 3, bringing it down, and times it with the log of 2. Okay, this is what really it means. So evaluate ln of 8, evaluate 3 times ln of 2 is exactly the same thing. Now the last property is what happens if you divide two numbers. So the input is x divided by y. And again, any memory for what the log does to a fraction. All of you try to remember this stuff because it's help you. Anybody? Okay. It's the log of x takes away the log of y. Okay, so in particular, the ln of x over y is ln of x minus ln of y. Every one of those property has to be memorized correctly. Okay, that's what matters is correctly. Now, what fails? Before I move on and practice those properties, okay, what fails? It means which properties don't work. So what fails? Okay, first, addition, it's something that we cannot always break. If you have a sum inside the log, you cannot break the sum. Crucial. If you have a sum, you cannot break it. So write clearly for yourself, you cannot break the sum. If you have a sum of two numbers, you cannot break them. What you break is the product. If you have a product, it turned into a sum. A sum remain a sum. You cannot touch that. The second property that confusing. If you have ln of x over y, you cannot break this. So this is not that divided by this. So we should not be confusing those properties of the log. So now with this in mind, I'm going to ask you again to evaluate a bunch of stuff. And I want all of you to be part of it. So evaluate. And you justify what you're doing. Evaluate the following. E to the ln of 2 quickly. Of course, you don't have a calculator at all, but I want answer to every one of those. That gives me 2 back. 2. E to the 3 ln of 2. And whatever answer, you have to justify it the best you can. 8. Y e to the 6. Now it is 8, and let me explain how. There are 2 ways to do it. One way is we can use the property of the log. 3 times ln of 2 is ln of 2 to the power 3. It's ln of 8. So here, I'll write it clearly. I'll write it down here. 3 times ln of 2 is ln, that's the property of the log, 2 to the power 3. It means ln of 8. So this will give me e to the ln of 8, which gives me 8. All right? Another way you can do this problem. Or you can say the following. E to the 3 times ln of 2, I'm going to use the property of exponent, is e to the ln of 2, the whole thing. Remember, ln of 2 is a number, so to the power 3. Which property of the exponent I used? I used the fact that a n to the m is a n times n. So 3 times ln of 2 is equal to that. E to the ln of 2 is 2 to the power 3, which is equal to 8. So you can look at this problem in 2 different ways. All right. Again, evaluate the following. So it's the same type of questions. E to the minus ln of 2. Please don't use your calculator because you guys know that you can't use it. So, all right, I get a half. Anybody for any other answer? Indefined. Why indefined? Remember, what's indefined, let's be very clear. If you have ln of a negative number, That's indefined. You're absolutely correct. But here I don't have ln of a negative number. I have ln of 2. The minus is outside, which is okay. So I don't have a negative inside the log. I have it outside. Okay, anybody agree with Ryan? Okay, Ryan, can you speak and tell me how did you get that? Or you can't speak? Okay, half is the correct answer, since 2 to the power minus 1 would be a half. Okay, so we're going to do this problem in two ways. One way and two ways. Okay, one way is to use the property of the log. Is e to the power ln of 2 to the minus 1. Okay, remember that. So here I'm using the following, sorry. Here I'm using the fact that ln of x is ln of x to the n. The power here is minus 1. So which will give me 2 to the minus 1, which is a half. That's one way. That's the way Ryan saw it. Can anybody see it in a different way? Can anybody give me another argument why it is a half? Anybody can think of another way, another argument for it. Okay, I'll help you out. This is a minus. And remember what we said yesterday. E to the minus something, it's 1 over e to the ln of 2. Okay, since you have e to the minus ln of 2, it means 1 over e to the ln of 2. 1 over e to the ln of 2 is 1 half. Okay, so you can either take this minus 1, raise it here, or you can say it's 1 over e to the ln of 2, which is a half. All right, again, along the same line. That's an easy one. What's ln of e squared? Anybody? 2. Okay, the last one is harder. Log base 2 of a minus log base 2 of 5. Okay, I'll give you 2 minutes to figure this out. 1 minute to figure this out. I want you to use the property of the log to figure out that. Okay, 4 question mark. Your answer is correct. But you guys have to walk me through your thinking process. Anybody else got 4? Okay. All right. So let us walk through them. Exactly 4. So let's walk through them. Since I have a minus in here, it's log base 2 of 80 divided by 5. So using the property of the log. It means log base 2. Now 80 divided by 5, that's going to give me a 116. Log 2 of 16, it means basically 16. So 16 is 2 to the power 4. It means equal to 4. Okay, we use all the properties of the log to be able to do that. All right. Okay, now log will be a very important function for us, but one of the main use for it, as you probably always remember, is to solve equation, mainly to solve equation where the unknown is a power. So let us recall how to solve this equation. So question is solve. Oh, sorry. Okay, solve the following equation. First, e to the x plus 3 equal to 2. Solve, it means I have an unknown and I have to solve. It means I want the power of x, to which power I should raise e to get the number 2. Okay, so let us recall how to do those problems. All right. The idea is whenever we solve, we try to find a way to isolate the x. That's really the bottom line. So now the x is an exponent. So how can we isolate it? And that's where we use the power of the logarithm. Because the logarithm tells me the following. Ln of one property, Ln of e to any power will give me the power back. So the idea is that I want to bring this. So the way we said, if this is equal to that, we're going to take the logarithm from both sides. And this would give me what here? This tells me that the log of the first term equal to the log of the second term. And now we use the power of the log. The log tells me that log of e to the x plus 3, it gives me x plus 3 back. This is the ln of 2. It means my x is ln of 2 minus 3. Okay, so if whenever we need to solve a problem where the power is the unknown, the log should come to our rescue. So two more problems along those lines. Okay. Suppose I ask you to solve the following problem. 5 times e to the power whatever, x plus 3 equal to 2. Again, solve. And my unknown is an exponent right here. So how would we start to do? What do you want me to do? Divide both by side. Exactly. Step 1 always is isolate the exponential term. Always we isolate the exponential term. We isolate it by dividing by 5 both sides. So it's going to give me e to the x plus 3 equal to 5th. Once I isolate it, then the log should come to the rescue. Another property of the log. Well, the log of e to the x plus 3 will give me x plus 3 back is ln of 2 over 5, which is 0.4. We know that. It means x would be ln of 2/5 minus 3. End of the problem. Okay. Last question along the same line is the following. Solve 5 times, let's say, 3 to the x equal to 4. Okay, so again, my unknown is an exponent. And whenever the unknown is an exponent, the log have to show up somewhere. So step number 1, isolate the exponential term. And that would give me 3 to the x equal 4/5. Step number 2, we take the natural log from both sides. Okay. And now we use the power of the log, the property of the log. One of the property of the log, one of the property that we use a lot is the following. Ln of x to a power is n times the Lx. So the power comes down. And that's exactly what I'm going to use here. So this is my power here, right there. And that's the one that's going to come down. So this would give me x times ln of 3 equal ln of 4/5. That's the way we're going to isolate my x. So this will give us the following. X equal ln of 3, which is a number, ln of 4/5. Or I can write this as ln of 4 minus ln of 5 divided by ln of 3. Over and over the property of the log. So whenever we have a known as an exponent, the log is the way to go. We isolate the exponent term and then we take the log from both terms and we satisfy. Does it matter whether you use, no, you can use anything you want. You can use the natural log, you can use the common log, you can use whatever log you like, okay? Now, another problem, sometimes we have the following issue. Okay, not sometimes. Sometimes we have to solve problems where our unknown is inside, so, okay, where our unknown is inside the log term. So suppose I tell you solve, I start with an easy problem. Solve ln of x equal to 2. Okay, so it means what x should I put here so that the ln will be 2? What do you think the answer is? Log n 2? No, because ln of 2 cannot be 2. ln of 2 cannot be 2. The question is, what should be this unknown? So the ln of it will be 2. Yeah, I want the x. Okay. First, one way to do it is to remember the definition of ln. ln of x equal to 2. So this one way, remember the definition. ln of x equal to, it means x is e squared. That's the definition of ln of x. What is ln of x? Is the power of e that gives me x. Now, if you forgot this definition, you know, how to solve this equation, ln of x equal to 2. What we should never forget is the following. Solving is isolating your unknown. How can I get the x outside the log? We have to get it out. We have to use the property that e to the ln of anything is the anything back. So if I want to get the x out of the ln, I need to take e to the ln. So what I'm going to do that, I say ln of x equal to 2, it means e to the ln of x equal e squared. This would help me to get the x out, which give me x equal e squared. So if my unknown is inside the log term, I take e from both sides so I can get the unknown out of the log. Okay, so one last example along the same line. Suppose I tell you to solve 6 times ln of x minus 3 equal to 4. It means what is the x? When I plug it inside this log, this equation is satisfied. So now my unknown is inside the log. So I have to find a way to get my unknown out of it. So how are we going to do that? Step number 1, isolate the log term. Isolate the log term. We isolate it by dividing by 6 both sides. Now I want to take x from inside. I will have to get rid of this. I say e to the ln of that is e, and a 6 is 2/3, e to the 2/3. And now I use the power of exponential and logarithm, which is always e to the ln of anything, e to the ln of anything is the anything back. That's the idea. So e to the ln of the x minus 3, this is the x minus 3, equal e to the power 2/3. It means x would be 3 plus e to the 2/3. Or you can rewrite this at 3 plus the cubic root of e squared, whichever way you like it. Okay, so whenever we have to solve a problem where the unknown is inside the ln, first we have to find a way to isolate the ln, whichever way. Once you isolate it, then you take the e from both sides. And this will help you to get your unknown out of the ln term, and then you solve it. Okay, I have. All right, so this is today's. The homework for Monday will be a combination of a worksheet I will give you, which is based on the lecture, and few problems from the book. Okay, do you guys have any questions before I let you go? No? Okay, good luck, and please do your homework, and I will, what, is this recorded? I think I recorded it. I will check in a minute. I think I did. Any other questions? Okay, see you guys on Monday, hopefully. Okay, have a wonderful weekend. Bye bye, guys. Okay.